Hi everyone. Sorry. Okay, thank you for coming to AWE today. So I'm Callie, and I'll be presenting about how we are exploring powered 3D generation for augmented reality experiences. And I'll be passing my time on to my co-presenters later, who'll be talking deeply about the models as well as scaling in the real-world context. So firstly, on the agenda we have today, which I'll be exploring, is the current challenges we are facing in augmented reality space, as well as the pipeline that we're going to be talking about today. So a bit different, we'll be doing a live demo. Instead of a live demo, we'll be doing a recorded video demo. And lastly, I'll be talking about the solution overview in my demo. And I'll pass on my time to my next colleagues as well. So when we talk to customers about building augmented reality experiences, we usually come up with 3 categories of challenges we hear in the space today. So firstly is team constraints. So I believe that those are in the space of augmented reality as well as creating 3D assets feel this constraint that we have, which is the skill sets needed to build our 3D assets in our team constraints. We often need specialized team assets for building the rigging, modeling, as well as the UV mapping of our assets. And this comes with specialized techniques that come with our skill sets. And we can't necessarily scale up as we need. If we need 100 assets for a production, we might have to hire a certain set of team with these skilled assets. And this might take time. As well as multiple artists also involve inconsistent quality. Maintaining the consistency across multiple artists is also a very hard nightmare to actually overcome. And next is the process bottlenecks that we might have to look through in developing a 3D assets. When we are developing an asset, which take weeks or even months, this has to go through multiple iterations of revamps from different teams. Different teams might also conclude that there may be further iterations needed onto the model, and this will be asking us to revamp the whole design all over again, which further creates the time needed for the assets to be created. And lastly, in today's market pressure, where we are constantly in demand for newer items quickly with higher quality, where the demand has grown from months to weeks to produce an asset, where new companies are creating new augmented experiences in different quarters, there's an increasing demand of companies to actually produce higher quality assets in the limited amount of time, as well as the team constraint that they do have. So we'll be addressing these challenges today through how we'll be going through our pipeline, which is using 3D generative models to actually create our 3D assets. So how 3D model generation actually accelerates your pipeline? We don't think of this as a new approach. We're thinking of AI as a starting point. We're not replacing artists, but we're actually giving them a new way of how they're going to work in today's environment. So firstly, artists spend most of the time on repetitive stuff. Let's think of basic modeling, UV mapping, as well as texture. This all takes time, where AI can actually help you handle this in seconds or even minutes. And this gives them time for what is actually needing the expertise, their creative direction, refinement, and making sure the whole creative direction is right in a certain direction. Your creative vision will stay within the team, but AI will actually generate different options as variations for your assets. This allows you to iterate quickly and also refine your assets quickly, which is what I mentioned earlier in our process bottlenecks. And lastly, where AWS comes in is the spinning and handling of your infrastructure capacity. So AWS can handle the compute infrastructure where you need GPU instances, and you can spin up instances and scale down as you need. So there isn't a need for hardware capacity where you have to plan ahead of time. And when you do need GPU instances, you can spin it up and spin down as you want. So you can only paying for the GPU instance when you need it. So this is a sample 3D model generation workflow, which I'll be demonstrating today. So for our pipeline, it involves 3 simple steps that we're exploring. Firstly, a text prompt. In this example, I'm creating a whimsical owl. And if you're familiar with the idea of prompt engineering, the more detailed a text prompt, the more detailed your outcome would be. So everything starts from the first prompt that you input. Next, from our text prompt, we're actually going to create a 2D image. In this case, we are using Stable Diffusion 3.5 Large as the image model. This intakes the text input and creates a high-quality 2D image, which will then be passed on to our respective 3D models, which our co-presenters will explain in detail later. In this case, I'll be demonstrating 3 different 3D generation models that are for 3 different use cases. We wanted to showcase different models in the market, as well as open source models available for use for everyone. Firstly, Stability AI 3D, which gives you a rapid prototyping iteration model that allows you to create a 3D assets in seconds or minutes. Next, Stable 3D Mesh, which gives you a high-quality mesh, which you can then refine on later with a next texture model, which is Step 1x 3D texture. So Step 1x 3D texture builds a texture model on top of our mesh generation. And now I'll be showcasing a video demo demonstrating the context of 3D asset pipeline in a context of a retail demonstration. So we actually created this solution particularly for the retail industry, but it can also be applied to other industries as well. So in this context, we're taking in the case of retail e-commerce, where they are helping their customers better understand the products through 3D augmented reality immersive experience. Firstly, visualizing your 3D assets. Customers, sorry. I think it will play. Yeah, so sorry about that. So first part is visualizing your 3D assets. Customers can now visualize their retail assets in their own mobile phones through augmented reality. Imagine if you're going through an e-commerce website and you'd like to purchase an item, you can now see it in augmented reality through your own mobile phones. Next is a text to 3D iteration, which I explained earlier, how you can use text to actually generate a 2D image of an asset, and how this 2D image is actually sent into our models to then create a 3D model. You can then visualize this 3D model in your own space. A next consideration is image uploads. So if people want to visualize certain images they see online in magazines, they can simply take an image of it, and this will go into our pipeline that will create a 3D asset. Imagine you see a sofa or furniture you saw in a magazine, and you want to visualize it in your own home. And lastly is how you can do image-to-image customization. This is especially powerful in the scale of visualization, where customers want customizability and also variations in their product. You have a sample image that you have, and you can have a text input to customize it. Let's say I have a sofa in a white cream context, and it doesn't match my interior design currently in my home. I want to customize it based on a certain prompt, where I want to make it brown, and how you can see that it respects the integrity of the original sofa, but still inputs the new customization, which is brown, and then you can visualize the new asset in your home. So what this gives to consumer is the product confidence. So when you're buying and purchasing product, you have more confidence in the product if you can visualize it in your actual environment. So this also expands out the scale for where retailers can actually sell to consumers different varieties of product. So now my co-presenter will be talking about the different models which I explained earlier.
And thanks a lot, Kelly. Hi, everyone. Good afternoon. My name is Lester, and I'm an AWS Solutions Architect as well. I'm based in Singapore, and I primarily cover startups in this region, so happy to connect after this event as well. There are 2 things that I'll be covering for today. One will be about the different kinds of open source models that we are seeing out in the field. We have selected a handful of them to showcase. And the next one is how do you run these 3D generation models that are GPU intensive on AWS itself. And each of these models that I'll be going through, they have slightly different underlying techniques that they use to generate a 3D mesh from images as inputs. So the first one is Stable Fast 3D. It's an open source 3D generation model. This is created by Stability AI team. And it uses the fast feed-forward technique to be able to generate your 3D mesh from a single image. So your input is a single image, and your output is most likely like a GLB file, the 3D mesh file. Now, with the fast feed-forward technique, it helps you to generate these assets rather quickly, in less than 0.5 seconds. It's also available as an API via Stability AI without the need to deploy your own infrastructure, or if you want, you can also deploy it on your own servers as well. Another open source model is Stable 3D Gen. It creates this high fidelity 3D geometry using a technique called normal bridging. So normal bridging uses normal maps as an intermediate step, so it converts your RGB images into normal maps first before it creates the 3D mesh. And the reason for that is that it will help you to generate, the normal maps help to create a little bit more depth information compared to RGB images. The last one that we are covering is Step 1x 3D. So again, it's another open source models. It uses a two-step process. You can think of it as you have a sculptor as well as a painter. So the first step, it creates your basic 3D shape, and it generates out the untextured mesh, and then after which it adds the realistic colors and the textures as well. So for the 3D mesh, it uses a diffusion model to create these 3D meshes. And then after that, it uses a fine-tuned version of Stable Diffusion to be able to generate out the textures from these images to ensure consistency. Now, these are some of the open source models, and there are a lot more open source models out there. And these are what we call as a single view model, meaning that I'm just using a single image as input to generate out the 3D mesh. There are other models, there are proprietary models as well, and there are other models like multi-view models, so that uses multiple images around a product so that you can generate a much more accurate 3D mesh of the product as well. So now that you have understood a little bit about the models, how do we run them on AWS itself? So let's take a look at the complete solution architecture behind, for example, the demo that Callie was showing earlier on. So this is an example of the architecture diagram. So the first thing that you see over here is that we have a front-end application. So for example, the demo website that we have is a Nix.js website, and we are running it on AWS Amplify. That is a managed service that we use for front-end developers to be able to deploy their full-stack applications. So your front end will be calling a bunch of backend APIs that will be all done through API Gateway. And then API Gateway will be calling a few Lambda functions. So AWS Lambda is our serverless compute functions. You can run your Python or Node.js scripts within those as well. So the first API that you want to call is a text-to-image or an image-to-image API that you will create. This points to our service called AWS Bedrock Service, Amazon Bedrock Service. It is a fully managed service again. It helps you to be able to call different kind of foundation models, text foundation models, image foundation models, and even video foundation models, all through a single API. Next, after you have generated out the image, so let's say the sofa image that you generated, you have to convert that into 3D. So to convert that into 3D, you will need to run those models, image to 3D models, on GPU servers. You have a few options of how you can run these models. So one option is you can deploy them directly on our servers, Amazon EC2. Second way is you can containerize it and run it on Amazon EKS. You can containerize it and also run it on SageMaker, which is our fully managed machine learning service for you to deploy your ML models as well. So depending on your team's familiarity with your tech stack, depending on the cost requirements, depending on some of the operational requirements from your team, that will help you to determine what to use to deploy these GPU intensive models. So the metadata that I've generated, like my job status, where my locations of these objects are created, would then be stored in Amazon DynamoDB, which is our NoSQL database. And then the final 3D object itself is actually saved in Amazon S3, which is our object storage service. So when we return back to the front end, it's returning back to them all these GLB files, or if it's an iOS, then you'll return and it will convert and return a USDZ file. So all these files are all stored in Amazon S3, and your front end is just pulling all these links from Amazon S3. If your team is familiar with Kubernetes, you can deploy everything within Kubernetes as well. So over here, what you see is the difference is your front end, your back end, the models itself, these are all deployed on Amazon EKS, Elastic Kubernetes Service. This part is about helping you to understand all the different types of Amazon EC2 instances with NVIDIA GPUs. So if you want to use NVIDIA GPUs, these are the virtual servers that AWS offers. The range of selection that you can choose from. So these 3D models usually will require NVIDIA GPUs if they leverage the CUDA toolkits to be able to enable your high-performance parallel computing, hardware-accelerated rendering. And these models are rather GPU memory intensive. So AWS do provide a range of GPU instances to run these workloads. So different instances actually have different kinds of NVIDIA GPUs. And different NVIDIA GPUs will also have different GPU architectures as well. So AWS will give you the flexibility. You are able to choose from your range of servers that you require. And let me walk you through some of these options. So what you see on this slide mostly are two instance families that are meant for accelerated computing. So one is the G instance type, so you will see from the first letter. And the second one is the P instance family. And then the number that's after the first letter will then represent the generation number, so the ones, the later ones. So like G6E will be later than G5 or G4. And then you have extra letters behind that just represents extra hardware capabilities like your G4DN, G6E, or the G7E. Yeah. So these are the range of EC2 instances that AWS provides for GPU capabilities. Now with that, I'll pass the time now to Jennifer to touch about 3D spatial data management on AWS.
Oh, thank you, Lester. And so I want to mention that generating 3D assets is half the challenge that a team usually encounters, and the other half may be managing, organizing, and delivering those assets at scale. This is particularly if you're like a game studio or something where you generate hundreds and thousands of assets for. So some of the challenges that in managing like a lot of 3D assets are data interoperability friction. So for example, you may have dozens of formats like FBX, OBJ, GLTF, USD, Collada, and more. And you may have a Unity team that needs one format, and then perhaps an Unreal team that needs another. And your web developers, for example, may need something else. And to solve that, you may want to build custom transformation pipelines for that, but that could be brittle or complicated or even expensive. So downstream-wise, if you have end users that need to manage or access any of that, that's something that may be a challenge. And also scalability and accessibility. A lot of times to access those assets, you may need expensive software licenses, and that may be an issue if you have to scale a lot of those assets to your end stakeholders like executives, marketing teams, or just sharing across multiple teams that may not have those licenses. And lastly, for ecosystem fragmentation, there's issues if you have to scale to over hundreds and thousands of assets, like museums typically have I would say several thousand, 100,000 images or videos or even potentially 3D models, of course. And I wanted to mention that AWS last December released a solution to address this issue. So it's called Spatial Data Management on AWS, or SDMA, available specifically in the Singapore region as well. And it's a no-code way to ingest, manage, and deliver spatial data at scale. And to break down what that means is it deals with the ingest as basically like importing, or as well as the management of the metadata, the search capabilities, and the versioning control of the files, as well as the delivery, which to handle the streaming of the files out to your endpoints or your CDNs. And Speaking of how it may work, here are some use cases that you may want to look at when considering this tool. So for example, the typical users or customers we've been in talks with, they may be in the automotive industry or manufacturing or defense or even museums. And oftentimes they may have use cases where they need to collaborate in real time or deal with immersive training or factory layout planning or robotics or quality traceability. And another use case that is often commonly used or need a use of a scalability tool are industrial scale operators like the utilities, energy, and oftentimes those use cases would be things like asset inspection, remote sensing, damage assessment and hazard detection, as well as planning, enhanced visual inspections, as well as real-time digital twins. So how does this look like in the AWS data plane? And I'll just go quickly in the interest of time. So in the ingest phase, that's where basically you import a lot of your assets. And a lot of the way that SDMA manages it is it has multiple, it basically manages and imports the data in multiple, in a management way where it will store it on top of S3. And so it also will pull in the metadata associated with each of the assets and manage that so that you don't have to manually tag that. And there's also an egress layer where you have APIs exposed to where you may need to stream the assets out and integrate it with even third-party applications. So as you see from the top, it moves from strategic planning to product design and product planning to simulation to production, as well as in your end delivery results for sales, marketing, and recycling and turnaround and service portions. So here's a video that kind of shows the UI, and just to kind of get this started. The quick look from what you see is the project file of the Wichita oil pump, and here you see a scene GLTF as well as a textures folder. And from there, it has PNG files as well as JPEG files. And you see when you open this up, there's the metadata auto-tagged as well. And you also have role-based access control, where if you have multiple teams, different teams can see certain assets and certain teams may not. So that's just like a quick preview of this. There are a lot more functionality available, but I just wanted to share just a quick view of what it may look like. So to wrap up, we want to mention some of the key takeaways and next steps for getting started with what we shared in this presentation. So the key things to keep in mind is we bring the know-how for democratizing 3D. So just note, this does not replace people. This is here as a tool to assist people. And this allows also accessibility so that anyone, even people without 3D expertise, can generate assets from just text descriptions or images in minutes or seconds. And this is here to also solve your business problem, because when there's constraints on your technology or pain point for bottlenecks or needing to scale for more content, this tackles the challenges on fundamental scaling within your team. And lastly, we just want to mention serverless is key. So when there's scalability issues that you may want to address in your architecture, you have the compute flexibility on AWS to manage your workloads in a serverless way. So as a call to action on how to get started on 3D generation on AWS, if you're interested, please reach out to one of our team. And in particular, we have two people from the physical AI and spatial computing team here to meet. And you can reach out on your use cases and also discuss about potential proof of concepts. And even like without reaching out to us, be sure to consider like downloading some of these free like options to test out and try and check with your internal work streams with your POCs. And you can also contact us if you're not builders for AWS Partner Help and AWS Advisory. Thank you so much for your time today. We're really excited to help you and in your content creation challenges and spatial computing initiatives. Be sure to connect and let us know your specific needs. Thank you.